Hi, Assalamualaikum and a very good day. So my name is Muhammad Ali Kamal bin FEM. Today I will be presenting the finite element analysis project or finite element method, the part of introduction and the conclusion of the project. So for the introduction of the project, we are selecting the car rim or car wheels based on for the real life engineering problem. So two static cases will be studied for this project. The first one is when the car wheel need to support the weight of the car itself and 4 passengers. And the second one, the same situation, but the car is moving at 80 km per hour. So in short, the analysis will be divided into three main parts, which is the von Mises stress distribution, displacement distribution, and factor of safety. So the aim of the project this project is to find the most suitable element size for each load cases in order to find the most accurate result based on the finite element analysis. So the simulation has been done and the result also has been checked and will be presented by my fellow friends. Thank you.
Hi, my name is Mong Sin Jing, and in this section I'm going to present load case 1. So load case 1, it is a static load case where the situation is we are going to determine how well the car wheels can support the weight of the car and 4 passengers. So we are going to study the effect of the rim based on 3 parameters. Number 1, we are going to look at the von Mises stress, and number 2, we are going to determine the displacement and deformation of the rim, and lastly, we are going to look at the factor of safety of the rim design. So to perform the study, we are going to use a mesh plot with element size of 8 mm, and in terms of fixture, the rim is fixed at the wheel hub and knuckle at the center of the rim. So talking about the force allocation, basically there are 3 kinds of forces in this simulation. Number 1, there is an inflation pressure of 50 pounds per square inches. This uniform pressure, which is equivalent to 0.345 megapascal, is exerted on the whole contact surfaces between the tire and the rim. So let's take a look into this figure. The blue color region is the contact area. The red arrows pointing towards the contact area represent the pressure. And apart from that, there is also a sidewall reaction. So the sidewall reactions with value 20,576 Newton are acting on the sidewall of the rim in contact with the tire. So the contact area here is represented in blue color, and the arrows here represent the sidewall reaction. Number 3, there is also a vertical force. So this vertical force is actually the vertical ground reaction. In this case, the value is 4,703.895 Newton. And this reaction is caused by the weight of the car, which is 1,670 kg, and also 4 adult passengers with the weight of 62 kg each person. The reaction is distributed along the angle of loading with 30 degrees. So the angle of loading here is represented in this triangle, and the contact area is in blue color. So the reaction force is pointed towards this contact area. So these 3 forces are mainly cause the deformation, the stress, and so on. So we are going to take a look into the effect and the result of our simulation in next section. First, we shall look at the von Mises stress distribution. So the left hand side, the figure here is showing the complete plot of the von Mises stress distribution at the rim. So the green region here represents moderate high stress, which is scattered around the rim lip and the spokes. So another observation is you can see the center disc is in complete blue region. So the blue region represents a lower stress distribution. In this case, there is only 10,310 Pascal. If you look at the right figure here, you can spot that there are 2 regions in red color. So the red color here represents the highest von Mises stress, which is 120.5 megapascal. So these two regions are considered as the most critical region in the rim. So this high stress is mainly due to the vertical force as mentioned above. So it creates a higher stress concentration in these two areas. The next plot is the displacement distribution plot. In this simulation, we are going to use a deformation scale of 101.539. So the reddish region indicates the highest displacement due to the high vertical ground reaction acting on it, but the inner part, there is no spoke to support the structure. So the higher deformation happens. Similarly, the lowest deformation is recorded at the center disk, which is represented in blue region. The displacement in center disk only records a value of 1 × 10⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻ deformation process can be visualized in this video, where the rim is being compressed and deformed. Next, we are going to look at the factor of safety distribution plot. So the formula of factor of safety is the yield strength of the material of the rim divided by the maximum stress, or we can call it design stress. So in this case, the material for the rim is alloy steel, which possess a yield strength of 620.4 megapascal. So after the simulation, we can see that the whole structure of the rim is in red region, which records a factor of safety of 5.15. So since the factor of safety is more than 1, which means that it will not fail in this simulation. In other words, the rim is able to support the car weight and 4 passengers safely and without failure. So these are all the results of the simulation we can get in case load 1.
Hi, first of all, thanks Wong for the previous presentation for log case 1. My name is Wajek Yang and I'm going to present for the log case 2. So, for log case 2, it is a static load when the situation is wheel rim is going to support the car with 4 passengers when moving forward at 80 km per hour. So, same as the log case 1, we're going to study about the bond missile stress, displacement or deformation, and lastly, factor of safety. Okay, so to get an accurate result, we're going to use element size of 8mm also for this log case, and also fix both hole at the wheel hub of the rim. In terms of boundary conditions, basically it's the same as the log case 1, but since it's moving, so we will apply one more force on the wheel ring, which is centrifugal force. For this log case simulation, after we apply all the forces on the wheel ring, we should run the study. As you can see, this is the animation for von Mises stress distribution plot. The highest stress of 118.1 megapascal is plotted at the lower part of the spokes. This is due to the vertical ground reaction, but since the car is moving at 80 km per hour, the highest stress is slightly lower than the stress at log case 1, and the lowest stress is 7,817 pascal, which is located at the center and ring lid of the rim. Next is the deformation distribution plot. So as you can see, there is red region spotted at the lower part of the ring, and the highest deformation on this ring is 0.4237 mm, and the lowest deformation represents blue region, which is 1 exponent negative 30 mm, which we can assume it as 0. This simulation shows that the wheel ring can support well even carry 4 passengers moving at 80 km per hour. Lastly, we're going to look at the factor of safety distribution plot. In order to obtain the factor of safety, we're going to apply the formula, which is L strength divided by the maximum stress of the motor. In this case, we apply the same material as log case 1, which is alloy steel with 620.4 megapascal. As you can see, the whole structure is in red with factor of safety of 5.255, which is very high, and it's good because for ideal wheel ring, it must be minimum 3 factor of safety. Since our model has exceeding the ideal one, it will not fail and ready to use on road at 80 km per hour with passengers. Okay, that's all from me for Logcast 2. Thank you for listening.
So for the conclusion of this project, based on the analysis, simulation and the simulation that has been done, the rim structure is considered safe to be in market based on its finite element analysis. So for the most accurate result is get by the element size of 8 mm. So why is it important to rim, or the rim to undergo the finite element analysis, as it need to ensure that the rim is safe and functional. So as that's for the conclusion, and that's all from us. Thank you very much.